Okay, we're going to work out REQ 4.3's number 3. It's asking you to write 1 to E base 12 into a base 10 numeral. Okay, so the thing to keep in mind is that each of these pieces, this is the ones place, and if it was base 10, it would be the tens place and the hundredths place. These are powers of 10, but it is not the power of 10 because it's a base 10. So this is still the ones place, or 12 to the zeros place. Let me see if I can write it out like this. Looking at kind of our place numbers. This is 12 to the zeros place, which is 1, 12 to the first place, which is 12, and 12 squared, which is 144. So this, in grade school, they used to do where they had these little single blocks, and then they'd have the long blocks of 10, and then they'd have like a 10 by 10 block, and you'd have so many of these, and so many of these, and so many of these together to give you like 235. And that was when they were teaching us base 10 as a child. This is the base 12 system, and this shows up in a couple different places. Computer science is the most natural application of this. They have I think it's dodecimal, something like that kind of system where they use this in translating computers. It's not the only place, I'm just giving you a general application. But so this E, in our case of the base 10 system, in any one digit you can have 0 up to 9, which is 10 different numbers. With the case of base 12, you could have 0 up to an 11. And if you look, they have 0, 1, 2, all the way up to 9, and then they have a T and an E. Their T represents 10, and their E represents 11. So this is 11 as we know it. So this is like 11, our base 10 singles, and then 2 bars of 12, and then 1 block of 144. So we have 144 times 1 plus 12 times 2 plus 1 times 11. So 144 times 1 is 1, 24 and 11. What's that? 168 plus 11. That would be 179 base 10, or as we know it, just 179. This is going the other direction. So they have given us 1,706 base 10, and they want us to compare this into base 2. Okay, and this is, base 2 is kind of, again, thinking computer science applications, is binary with a string of zeros and ones. Oh, I'm sorry, they did this example, pardon me. They want us to do 21 base 10 and change that into base 2. So what we're going to do for the base 2 is we're going to kind of set up the place values. Okay, it always starts with the ones place, or 2 to the 0, the base to the 0, which is equal to 1, 2 to the first, which equals to 2 in this case, 2 squared, which is 4, 2 to the third, which is 8. Let's see if we need more than that. 2 to the fourth is 16. That looks like 24. That is 2 to the fourth power. And then 2 to the fifth will take us up to 32. Now, considering that we have 21 individual pieces, 32 is more than we need. So we know that if we were to have a 1 right here, we have a block of 16. If we have 1 of those 21, we've accounted for 16. That's what, 5 left over. So 5 pieces, 8 would be too big, so we're just going to need 0 of those pieces. 4, well, if we have 1 of those, we have 1 left over. How many blocks of 2? Well, 0. And then how many blocks of 1? We just have 1. So our answer here would be 10101. And that in base 2 is equivalent to 21 base 10.